Welcome back to our next series in our statistical lectures. In this video, we're going to start looking at how to assess bivariate relationships. That is, we're trying to assess now if an independent variable x is correlated with a dependent variable y. At its most basic level, when we're talking about correlation, we're saying that some values of x are more likely to be associated with some values of y. For example, if we had a dichotomous variable, let's say gender, male, female, and we had another dichotomous variable, whether or not a student passed the course, we could try to assess whether or not gender was related or correlated to passing a course. We can think about sort of the values that might look like. So if we found, for instance, out of 100 people, 50 male students passed the course and 50 female students failed the course, that would be strong evidence that there is a relationship between male-female and success in the course. Contrast that with an alternative scenario where, let's say, there's 25 males who passed the course, 25 females who passed the course, 25 males who didn't pass the course, and 25 females who didn't pass the course. There would be no pattern between passing the course and gender, since half the male students passed and failed the course, and half the female students passed and failed the course. So what we're trying to do is come up with a way to assess or measure that outcome, or assess and measure those differences in outcomes. How do we come up with measures that are going to showcase where, let's say, all the males pass the course and all the females don't pass the course, versus a scenario where half of the males pass, half of the females pass, and there is no relationship. So before we kind of get into how we calculate those statistics, it's important to keep in mind the levels of measurement we talked about in our earlier videos. So you may recall from those earlier videos that there are essentially 4 functional levels of measurement for statistical analyses. There are nominal variables, which assign numeric values to unranked categories. For example, 1 white, 2 black, 3 Hispanic. There are dummy variables, which are a special case of nominal, where we have only 2 categories, typically assigned 0 and 1. We've got ordinal variables, which are ranked categories, say 1, 2, 3, 4, low, medium, medium, high, and high. And finally, we have interval/ratio variables, which essentially turn into continuous variables for statistical analyses. Now, with that in mind, our first tool we're going to talk about is really designed for the first 3 types: nominal, dummy, and ordinal. So anytime you have a categorical variable, you can match it or analyze it along with another categorical variable in what we call a cross-tabulation or a contingency table. Let's take a look at how that works now. Alright, so let's take a look at how we create a crosstab. So we're going to start with our independent variable, which we'll call x, and we're going to start with our dependent variable called y. Now remember, crosstabs are for categorical variables only. So we're going to say here that independent variable x has k categories and dependent variable y has m categories. In most typical setups, we list the values of y on the rows and we list the value of x on the columns. So in order to find the total number of cell entries for our crosstab, we multiply m, which is the number of values of y, against k, which is the number of values of x. So for instance, if we have 2 dummy variables, both variables would have 2 values, presumably a 0, 1 for x and a 0, 1 for y. M would be 2 and k would be 2, so we'd multiply 2 times 2, and that would give us 4 cell entries for our crosstab. Alright, so let's look at an example using our student data from one of our previous videos. So here I've got 25 students, and their names are listed in column A. I have a variable called standing, which is coded 1 for first-year students, 2 for sophomores, 3 for juniors, and 4 for seniors. And I have a numeric value for their grades. In this case, 4 is A, 3 is B, 2 is C, and 1 is D. So if we kind of think about the way this is broken down, we know that standing is a 4-category variable. Once again, 1, 2, 3, 4, freshman, first year, sophomore, junior, senior. And grade num is also a 4-category variable because we know that we can have A's, B's, C's, or D's. So we know then that with our 4-category X variable, which we'll call class standing, and our 4-category grade number variable, that we can figure out the total number of cells by multiplying 4 times 4, which gives us 16 cell entries. We also said before that in general we want to list the values of the y variable, which in this case we'll call grade num, or grades, down on the rows, or we're going to list the x values, which in this case will be class standing, on the columns. So once again, our grades are 4, which we said were A's. We've got 3, which is B, 2, which is C, and 1, which is D. And here we're going to list our standing variable. And here we've got 1, which we said was for first year. 2, we said was sophomore. 3, junior. And 4, senior. So now it's a matter of filling in the individual cells, which we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, filling in the cell entries for our cross-tabulation or contingency table. So if we're doing this by hand, we're going to first find the number of first-year students that received an A and fill in that count for this cell entry. So let's go back to our original data. We're looking for class standing of 1 and then a grade of 4. So here's 1, 2, 1, 2, 1, 3, 1, 2, 1, 1, 1, 2, 1, 3, 1, 1, 1, 2, 1, 3. It doesn't look like we have any 1, 4s, so we're going to put a 0 in the cell entry. Now we're going to look for 1s and 3s, so first year students who got B's. So we've got 1, 2, 1, 2, 1, 3. Here's a 1, 3. So just to show that we've counted this one, I'm going to shade that box in. We've got a 1, 2, a 1, 1, a 1, 2. Here's another 1, 3. So let's shade that in. A 1, 1, and we have another 1, 3. Shade that in. So here we have 3 1, 3s. That is 3 students who had B's in their first year. Now we're looking for 1, 2s, first year students that got C's. So here we have a 1, 2. Shade that in. We've got another 1, 2. We've got a third 1, 2. A fourth 1, 2. And a fifth 1, 2. So we'll put a 5 in for this cell entry. And now finally we're going to look for 1, 1s, first year students that got D's. So we've got 1, 1, 1, 1. So 2. Now we're going to go to the next column and we're going to look for sophomore students that got A's. So we're looking for 2s and 4s. So we've got 2, 3, 2, 2. Here's a 2, 4. We've got a 2, 3, 2, 2, 2, 2. Here's another 2, 4. Another 2, 4. 2, 3, and a 2, 2. So we've got 1, 2, 3. 3 sophomores who had A's. Now let's look for sophomores who had B's. So looking for 2s and 3s. So here we have a 2, 3. 2, 3. So that's 2, 2, 3s. 2, 2, 2, 2, 3. 2, 3. So we have 3 2, 3s. Now we're looking for 2, 2s. We've got 1, 2, 3, 4. We have 4 2, 2s. And now we're looking for numbers of sophomores who had D's, so 2, 1s. So we're looking for 2s first. There are no more 2s, so we know that this number is 0. Moving on to juniors with A's, so 3 4s. So here's a 3 4. And it looks like we only have 1 3 4. Now we're looking for 3 3s, juniors with B's. There's one here, one here, and it looks like that's the last junior we have, so 2. Then we have 0 juniors with C's, 0 3 2s, and 0 3 1s. Finally, we're looking for seniors with A's, so 4 4s, well, there are none. Seniors with B's, and we've got 1. We've been looking for seniors with C's, so 4 2s. So there's 1. And finally, we're looking for seniors with D's, 4 1s, but there are no 4 1s, so we'll put a 0. So pretty much at this point, our cross-tabulation is mostly complete. The only thing that you'd really see added in a computer program like SPSS is a total column and a total row. So here we're going to sum for the column. We have 0 plus 3 plus 5 plus 2. So 3 plus 5 is 8 plus 2 is 10. So we know we have 10 first-year students. We're going to add down the column for sophomore students. We have 3 sophomore students plus 3 sophomore students plus 4. So 3 plus 3 is 6 plus 4 is 10. Counting the juniors, we're going to count, we've got 1 plus 2 plus 0 plus 0, so 1 plus 2 is 3. And for seniors, we've got 0 plus 1 plus 1 plus 0, so 2. How many students got A's in the class? We've got 0 plus 3 plus 1 plus 0, so 4. How many students got B's? 3 plus 3 plus 2 plus 1, so we've got 3 plus 3 for 6, plus 2 is 8, plus 1 is 9. For C's, we've got 5 plus 4 plus 0 plus 1, so 5 plus 4 is 9, plus 0 is 9, plus 1 is 10. And we've got for D's, 2 plus 0 plus 0 plus 0, which is just 2. Now, if we've done all of our math right, the sum of the row totals and the sum of the column totals should all be the same number, n, in this case 25. So 10 plus 10 plus 3 plus 2 would be 10 plus 10 is 20, plus 3 is 23, plus 2 is 25. So we know our column totals are right. Looking at our row totals, we've got 4 plus 9 plus 10 plus 2. 9 plus 4 is 13, plus 10 is 23, plus 2 is 25. So we've hit our right number for n, and our cross tabulation is now complete.